We often think of Rome as a city of art, but the truth is far more violent. The empire was built on the backs of machines designed to crush everything in their path. It was a world of engineering where the battlefield became a laboratory of destruction. From giant towers to spikes that shattered bone, the Roman military was centuries ahead of its time. How did a single city turn the known world into its personal fortress? What terrifying technology allowed soldiers to dismantle a city wall in a single afternoon? Stick around, because once we look past a marble to uncover the cold, hard steel of the Roman war machine, you will never look at history the same way again. We will explore the invention that turned a simple army into an unstoppable force of nature. Let us begin with the tools of absolute domination. What if the secret to conquering the sea was not becoming a better sailor, but bringing the ground with you? Imagine the year 264 BC. The Roman Republic was a master of the Italian soil, but its horizon stopped at the shoreline. Across the water sat Carthage, a maritime superpower with a navy that had spent centuries perfecting the art of the ram and the sail. To the Carthaginians, the Romans were amateurs. They were landlocked soldiers in sandals who did not know a mast from a steering oar. But the Romans possessed a gift for something the ancient world had never seen on this scale. They were masters of adaptation and brutal efficiency. They did not just want to survive the waves. They wanted to own them. To do that, they needed a machine that would bridge the gap between their greatest weakness and their legendary strength. This machine was a corvus. It was a tool of such sudden and violent innovation that it changed the course of history in a single afternoon. Before the corvus, Roman naval strategy was non-existent. In the early days of the First Punic War, Rome realized they could not win by simply marching their legions to the coast and shaking their fists at the horizon. They needed ships. Legend tells us that a Carthaginian quinquereme, a massive state-of-the-art galley with 5 banks of rowers, washed up on a Roman beach after storm. Instead of just admiring the wreckage, Roman engineers swarmed over it. They took it apart piece by piece, mapping every timber and every joint. This was not just curiosity. It was industrial espionage. Within weeks, the Romans had built a fleet of over 100 ships based on that single stolen design. But there was a problem. A ship is only as good as the men who sail it. The Romans were not sailors. They were infantrymen. They lacked the decades of experience required to maneuver a heavy galley into position to ram an enemy. If they tried to fight a traditional sea battle against Carthage, they would be outmaneuvered and sunk before they could even draw their swords. This is where Roman ingenuity turned a disadvantage into a death trap. They realized that if they could not beat the Carthaginians at being sailors, they would force the Carthaginians to be soldiers. They designed the corvus, a heavy boarding bridge that would turn a sea battle into a land battle. The word corvus means raven or crow in Latin. It earned this name because of the massive, curved iron spike attached to the bottom of the bridge. This spike looked exactly like the beak of a predatory bird, and it was designed to strike with the same lethal precision. The bridge itself was a massive wooden plank, roughly 36 feet long and 4 feet wide. It was mounted on a swivel at the front of the Roman ships, held upright by a system of pulleys and a tall wooden pole. The engineering was as simple as it was terrifying. As a Roman ship approached an enemy, the crew would wait for the perfect moment of proximity. With a sudden release of the ropes, the heavy bridge would crash down onto the enemy deck. The iron beak, driven by the sheer weight of the timber, would smash through the wooden planks of the opposing ship. Once the spike was embedded, the two vessels were locked together in a violent embrace. The enemy could not pull away. They could not use their superior speed or their bronze rams. They were anchored to the Roman vessel, and the bridge created a stable, wide path for the Roman legions to charge across. This was the moment the battle ended for Carthage and began for Rome. The Roman soldiers did not need to know how to row or how to read the wind. They only needed to know how to march. Clad in their heavy armor, shields raised and gladiator swords drawn, they stormed across the Corvus in tight, disciplined ranks. The Carthaginian sailors, who were often lightly armored and trained for rowing rather than close-quarters combat, were suddenly facing the most feared infantry in the Mediterranean on their own decks. The Corvus did not just link two ships. It exported the Roman way of war onto the water. It was a machine of psychological and physical domination that stripped away the enemy's advantage in an instant. The first major test of this machine came at the Battle of Mylae in 260 BC. The Carthaginian fleet approached with total confidence. They saw the Roman ships as clumsy and slow. They even laughed at the strange wooden structures standing on the Roman prows. They did not understand what they were looking at until it was too late. As the ships closed in, the Romans dropped the ravens. The sound of splintering wood and the sight of the iron beaks sinking into their decks turned their laughter into screams of panic. 30 Carthaginian ships were captured in the opening minutes of the engagement. The Roman commander, Gaius Duilius, became a hero overnight. For the first time in history, Rome had defeated a naval superpower on the high seas. They did it using a machine that turned the unpredictable ocean into solid ground. But the Corvus was more than just a bridge. It was a masterpiece of mechanical tension and leverage. The bridge had a railing on both sides to prevent soldiers from falling into the sea during the chaos of the charge. It was wide enough for two men to run side by side, ensuring that a steady stream of reinforcements could flood the enemy ship. The pulleys were designed for rapid redeployment. If one ship was cleared, the Corvus could be raised and dropped onto another target nearby. It allowed a single Roman ship to become a mobile platform for an entire company of soldiers. At the Battle of Ecnomus, which was one of the largest naval engagements in human history, the Corvus was used to manage hundreds of simultaneous boarding actions. The scale of the carnage was industrial. Rome was no longer just a city on 7 hills. It was a predator of the deep. However, as with many of Rome's most extreme war machines, the Corvus came with a heavy price. It was a massive, top-heavy structure of oak and iron. Placing such a heavy weight so high on the prow of a ship made the vessels dangerously unstable. In calm water, the Corvus was a weapon of absolute victory. In a storm, it was a liability that could capsize an entire fleet. Historical records suggest that Rome lost hundreds of ships and thousands of men to the sea, not because of enemy action, but because the weight of the Corvus made their ships impossible to steer in rough weather. Eventually, as Roman sailors became more experienced and learned the traditional art of naval maneuvering, the Corvus was phased out, but its impact was already permanent. It had given Rome the foothold it needed to break the Carthaginian monopoly on the Mediterranean. The raven's beak was the ultimate expression of the Roman mindset. It was a machine born of necessity and built with the cold logic of a conqueror. It showed that the Romans were not afraid to abandon tradition if a better tool could be forged. They looked at a ship and did not see a vessel. They saw a floating foundation for a fortress. They looked at the sea and did not see a barrier. They saw a new road for their legions to march upon. This ability to weaponize engineering is what set the Roman military apart from every other power of the time. They were not just fighting battles. They were solving problems with wood, iron, and blood. By the time the Corvus disappeared from the decks of the Roman navy, the Mediterranean was no longer a Carthaginian lake. It was becoming a Roman sea. The machine had served its purpose. It had seized the initiative and forced the world to play by Roman rules. This was the beginning of an era where no wall, no distance, and no ocean could protect an enemy from the reach of Rome's mechanical might. If the ballista was the sniper rifle and the onager was the heavy artillery, the corvus was a bridge to empire. It proved that once the Roman engineers set their minds to a task, the laws of nature and the traditions of warfare were merely obstacles to be crushed. As we look further into the machines that followed, we see the same pattern of brutal innovation repeating again and again. Rome did not just win. They engineered a world where it was impossible for them to lose. The Mediterranean was just the first of many laboratories where Roman war tech would be tested to its most lethal limits. If you were a warrior standing on a wooden wall or a hill, the last thing you wanted to hear was a collective snap of 1,000 twisted ropes. Before you could even see the Roman infantry, you would feel them. A low, mechanical hum followed by a whistle that sliced through the air. This was the ballista. It was the ancient world's answer to the modern sniper rifle, a weapon that didn't just kill, but paralyzed an entire army with the threat of invisible, high-speed death. While other cultures relied on the strength of a man's arm or the simple curve of a wooden bow, the Romans looked to the battlefield and saw a problem that could be solved with mathematics and machines. They didn't want to just shoot arrows. They wanted to launch projectiles with the force of a falling building. The ballista was the pinnacle of Roman torsion technology. It worked on a principle so advanced that it wouldn't be truly surpassed until the invention of gunpowder. At its core were two massive bundles of twisted fibers, usually made from animal sinew, horsehair, or even human hair in times of extreme crisis. These bundles were held in place by bronze or iron frames and acted like biological springs. To fire the machine, soldiers used massive winches to pull back the arms, twisting those bundles even tighter until they held a terrifying amount of potential energy. When the trigger was released, that energy didn't just push the projectile, it exploded into it. A heavy iron-tipped bolt launched from a ballista didn't arc gracefully through the sky like an arrow. It traveled in a flat, violent line. It was designed to punch through shields, iron breastplates, and the man behind them without slowing down. Roman engineers were obsessed with the calibration of these machines. They didn't just build them and hope for the best. Every ballista was a product of precise calculations based on the diameter of the torsion spring. The Romans had specific formulas to determine how much energy was needed to launch a bolt of a certain weight over a specific distance. They used bronze gears and notch plates to ensure that the tension on both arms was perfectly equal. If one side was tighter than the other, the shot would veer off course. But a well-tuned Roman ballista was accurate enough to pick off an individual commander from hundreds of yards away. This was the art of long-range terror. It changed the psychology of war. Suddenly, no one was safe, not even the leaders standing far behind the front lines. But the Romans didn't stop with large, stationary machines. They realized that for an army to be truly unstoppable, their artillery had to move as fast as their men. This led to the creation of the Scorpio. Think of the Scorpio as a little brother of the ballista, but what it lacked in size, it more than made up for in speed and cruelty. It was small enough to be operated by a single person or a small team, and it could be mounted on a wooden stand or a cart. During the height of the empire, every Roman legion carried at least 60 of these machines. They were the first true form of mobile field artillery. Imagine a line of legionaries advancing toward you, and behind them, dozens of these mechanical wasps being cranked into position. They could fire up to 4 bolts a minute. In a field battle, a battery of Scorpios could unleash an iron rain that would shatter a charging line of infantry before they ever got within sword's reach. The sound alone was a weapon. Ancient writers described the rhythmic thud and snap of the machines as a sound that could break a man's spirit. Julius Caesar understood this better than anyone. During his invasion of Britain, the native tribes were terrified by the strange, multi-armed machines they saw mounted on the decks of the Roman ships. They had never seen anything like it. As the ships approached the shore, Caesar ordered the ballistae and Scorpios to open fire. The defenders, who were used to traditional spears and arrows, were suddenly faced with heavy bolts that could split a wooden shield in two. They retreated not just because they were being hit, but because they couldn't understand how the Romans were reaching them from so far away. It was a demonstration of technological superiority that made the actual combat almost unnecessary. One of the most famous and grisly accounts of the ballista's power comes from the historian Procopius. During a siege, he described a Gothic warrior who was wearing a thick suit of armor and standing high up in a tree, firing arrows down at the Romans. A Roman engineer aimed a ballista at him and pulled the trigger. The bolt was traveling with such force that it didn't just kill the man. It drove right through his metal chest plate, through his body, through the back of his armor, and pinned him deep into the trunk of the tree. The warrior was left hanging there, suspended in midair by the bolt, a gruesome warning to every other defender on the field. This wasn't just a casualty. It was a message. The Romans were telling their enemies that their armor was useless, their walls were temporary, and their lives were at the mercy of a machine. The versatility of the ballista was another reason for its success. It wasn't just for land battles. The Romans mounted them on the bows of their warships to clear enemy decks before boarding. They placed them on the top levels of their massive siege towers to provide covering fire for the troops inside. They even created a version called the carroballista, which was essentially a ballista mounted on a horse-drawn carriage. This allowed the Roman army to have horse-drawn snipers that could move to any part of the battlefield that needed support. If a gap opened in the Roman line, the carroballisti could rush in, fire a few devastating volleys, and retreat before the enemy could react. It was a level of tactical flexibility that their opponents simply couldn't match. What truly made these machines terrifying was the Roman commitment to mass production. While a Celtic tribe might have a few master craftsmen who could make high-quality bows, the Romans had entire military factories dedicated to producing interchangeable parts for their artillery. If a bronze cap broke in the middle of a desert in Syria, the Roman engineers had a replacement part that would fit perfectly because it was made to a standard design. They carried spare sinew, spare winches, and thousands of pre-made bolts in their baggage trains. This meant that the Iron Rain never had to stop. As long as the Roman supply lines were open, the machines would keep firing. They turned the chaos of battle into a systematic, industrial process. The men who operated these machines, the ballistae, were more than just soldiers. They were specialists who occupied a unique place in the Roman hierarchy. They had to be part mathematician, part carpenter, and part killer. In the heat of battle, they had to estimate distances, adjust for the wind, and keep the machines firing while under a hail of enemy arrows. This level of specialization was a hallmark of the Roman military system. They understood that a machine is only as good as the man operating it. By creating a professional class of artillerymen, Rome ensured that their high-tech weapons were always used with maximum efficiency. This wasn't just about having the best tools. It was about having the best system for using those tools. The materials used in these machines also speak to the reach of the empire. To create the perfect torsion spring, the Romans sourced hair and sinew from across their territories. They found that certain types of animal gut were more resilient in the damp forests of Germania, while others performed better in the dry heat of North Africa. They experimented with different types of wood for the frames, choosing oak for strength or ash for flexibility. This level of material science allowed them to maintain their artillery in any environment. While an enemy might hope that the Roman machines would rot in the rain or warp in the sun, the Roman engineers had already planned for it. They wrapped their torsion bundles in leather and coated their wooden frames in wax and oil. It was a total commitment to dominance through engineering. We also have to look at the defensive side of this technology. The existence of the ballista changed the way cities were built. Ancient architects began designing walls with rounded towers and thicker foundations specifically to deflect or withstand the impact of Roman artillery. But the Romans just responded by building bigger machines. They created ballistae that could throw stones weighing over 100 pounds, capable of shattering the very walls that were meant to be safe. It was an arms race that Rome almost always won. They had the resources, the mathematical knowledge, and the cold, hard discipline to use these machines to their maximum potential. They didn't see the ballista as a luxury. They saw it as a necessity. It was a tool that allowed a smaller group of disciplined men to dominate a much larger, more disorganized force. The impact of the ballista on the ancient world cannot be overstated. It was the first time that technology truly dictated the terms of engagement. It forced armies to stay in cover. It forced commanders to rethink their strategies, and it made the Roman legionary the most feared soldier on the planet. But as deadly as a ballista was, it was only one part of the Roman arsenal. The Iron Rain was designed to pin the enemy down, to break their formations, and to kill them from a distance. But what happened when the walls were too thick for bolts? What happened when the Romans needed to move from precision to pure, raw destruction? That is where we meet the beast of the Roman army. A machine so violent it was named after a kicking wild animal. If the ballista was a sniper rifle, then the next machine we are going to discuss was a heavy sledgehammer that leveled cities. This was the onager, a single-armed monster that traded precision for absolute power. While the ballista focused on the individual, the onager focused on the structure. It was a weapon that turned stone into dust and silence into screams. It used a different system of torsion, a single massive bundle of rope that held enough tension to shake the ground every time it was released. To understand how the Romans truly broke the world, you have to understand the violence of the onager. But before we get into the mechanics of that mechanical beast, we have to appreciate the sheer scale of Roman engineering. They didn't just build weapons. They built a system of war that integrated every piece of technology into a single lethal machine. The ballista provided the range. The Scorpio provided the speed. And as we will see, the onager provided the final, crushing blow. Rome was no longer just an army. It was an engine of conquest that was just beginning to hit its stride. To a Roman general, a city wall was not an ending point. It was a mathematical problem waiting for solution. While other ancient cultures looked at massive stone fortifications and saw an impossible barrier, the Romans saw an opportunity to demonstrate why they were the masters of the physical world. If a wall was too high to climb, they built a machine taller than the wall. If a gate was too thick to break, they engineered a device that could strike with the force of a mountain. This was the era of the walking fortress and the calibrated hammer. In this segment, we go beyond the battlefield and look at the terrifying structures that made every city in the Mediterranean realize that no matter how thick their stones were, the Romans were coming through. Imagine standing on the ramparts of a city like Jerusalem or Carthage. You look out across the horizon, and you see something that should not be possible. A tower as tall as a 10-story building is slowly, methodically rolling towards you. It is covered in the raw, wet hides of slaughtered oxen to prevent your fire arrows from catching. It is reinforced with iron plates that glint in the sun. As it gets closer, you realize it is not just a building. It is a hive of organized destruction. This was a Roman siege tower, the ultimate expression of engineering use as a weapon of psychological and physical dominance. The construction of these towers was a feat of logistics that seems incredible even by modern standards. Roman engineers did not just throw wood together. They used modular designs that could be pre-assembled or built rapidly using local timber. These towers were often built to be exactly 5 feet taller than the walls they were attacking. This was done so that the Roman archers and light artillery on the top floor could fire downward, clearing the battlements of defenders before the main assault began. Inside, the tower was a labyrinth of ladders and platforms. On the lower levels, hundreds of soldiers or teams of oxen worked in unison to push the massive structure forward on heavy wooden rollers. On the middle levels, a massive bridge called a sambuca or a simple gangplank was held in place by heavy ropes and pulleys. When the tower finally reached the wall, the impact was more than physical. It was the sound of a drawbridge slamming onto stone and the roar of hundreds of legionaries charging out of the belly of the machine. The Romans understood that if they could get their infantry onto the wall in a tight, disciplined formation, the siege was essentially over. But getting the tower to the wall was the real challenge. If the ground was uneven, the Romans did not turn back. They changed the earth itself. At the siege of Marsada, the Romans faced a fortress sitting on top of a jagged, isolated plateau. Most armies would have looked at that cliff and walked away. The Romans stayed for months and built a massive ramp of earth and stone that reached hundreds of feet into the air. They literally moved a mountain so they could roll their siege engines up to the gate. It was a message to the world that not even geography could protect you from the will of Rome. But what if the tower was not enough? What if the walls were too thick for a bridge to reach? That is when the Romans brought out the hammer of the empire. The battering ram was an ancient tool, but the Romans turned it into a methodical system of demolition. A Roman ram was not just a log carried by men. It was a massive beam of oak or fir, sometimes over 100 feet long, tipped with a heavy iron head shaped like a ram. This beam was suspended by thick iron chains from a wheeled frame known as a testudo or tortoise. By hanging the ram rather than carrying it, the Romans could create a pendulum motion. This allowed a relatively small group of men to swing a multi-ton weight with incredible speed and rhythm. Each strike of the ram was a calculated blow. The iron head would bite into the mortar and stone, sending vibrations through the entire structure of the wall. With enough time and enough strikes, even the most massive stones would begin to crack and shift. The protective shed around the ram was draped in soaked hides and reinforced with planks to protect the crew from boiling oil, rocks, and arrows. Inside that wooden shell, the sound must have been deafening. The rhythmic boom of the ram hitting the gate was the heartbeat of a dying city. Roman law even had a specific rule about this. It was called the right of the ram. Once the head of the ram touched the wall of a city, the time for negotiation was over. No mercy would be shown to the inhabitants. The first strike of the machine was a formal announcement that the city now belonged to the flames. The engineering did not stop at simple impact. Roman engineers were constantly innovating to overcome specific defenses. If a defender tried to drop heavy rocks to break the ram, the Romans would build slanted roofs on their shed to deflect the weight. If the defenders tried to catch the ram with giant hooks or chains, the Romans would attach sharp blades to the frame to cut the ropes. They even developed a version of the ram called the terebra or the bora. This was a smaller, more pointed beam that was twisted or pushed into the gaps between stones to pry them apart from the inside out. They were treating a city wall like a puzzle, finding the one weak point and applying pressure until the whole thing collapsed. We often think of these machines as being used only on land, but Roman ingenuity extended to the waves as well. During naval sieges, they would lash two heavy warships together to create a stable platform. On top of these ships, they would build smaller versions of their siege towers and bridges. This allowed them to attack sea walls and harbor forts directly from the water. The sight of a floating fortress rising out of the Mediterranean mist must have been one of the most terrifying things an ancient sailor could imagine. This adaptability was what made the Roman military machine so effective. They did not have one way of fighting. They had a library of engineering solutions for every possible obstacle. The true secret of Roman siege warfare, however, was not just the machines themselves, but the coordination between them. A siege was a symphony of destruction. While the battering ram was working at the base of the wall, the ballistae and onagers we discussed earlier were raining stones and bolts onto the towers above. At the same time, the siege tower was moving into position to drop its bridge, and specialized units of miners were digging tunnels underneath the foundations of the wall to make them collapse. The defenders were attacked from below, from the front, and from above all at once. There was no place to hide and no way to focus their defense. This was the Roman way of war. It was expensive, it was slow, and it required a staggering amount of labor. But it was nearly impossible to stop. When Rome decided a wall had to fall, that wall was already gone. It was just a matter of how much wood and iron they needed to use to prove it. The siege machines were the physical manifestation of Roman patience and discipline. They were willing to wait. They were willing to build, and they were willing to out-engineer anyone who stood in their way. These machines turned the art of the siege into a cold, hard science. As we look closer at how these soldiers lived and fought, we see that this same level of detail was applied to every piece of equipment they carried. The machines broke the walls, but it was the gear on the back of the individual soldier that finished the job. If the ballista was the sniper rifle of the ancient world, then the Roman onager was its heavy demolition hammer. It was a machine defined not by grace or precision, but by pure, unadulterated violence. While other engines of war hummed and snapped with the sound of a bowstring, the onager roared. It shook the earth, it cracked the air, and it brought down walls that had stood for centuries. But to understand why this machine was so effective, we have to look past the heavy timber and the massive stones it threw. We have to look at the physics of wood, sinew, and stone. We have to look at the engineering that allowed a group of soldiers to turn a pile of organic materials into a weapon that could strike with the force of a modern explosion. The name onager was not chosen by chance. It refers to the wild ass of the desert, a creature known for its powerful and unpredictable kick. Roman soldiers, who were never shy about giving their gear nicknames, watched this machine fire and saw a resemblance. When the heavy wooden arm of the catapult reached the end of its arc, it slammed into a padded horizontal beam with such ferocity that the entire rear of the machine would jump off the ground. It was a literal kick of metal and oak. This recoil was so intense that it became the defining characteristic of the weapon. It was a beast that had to be tamed every time it was fired. If you place an onager on a stone fortress wall, the vibration alone could rattle the masonry loose, eventually causing the very platform it sat on to collapse. This was raw power, harnessed and directed at Rome's enemies. But where did that power come from? In a world before gunpowder and steam, the Romans had to find a way to store massive amounts of potential energy. Their solution was a torsion spring. At the base of the onager sat a heavy, rectangular frame made of thick oak beams. Inside this frame, engineers stretched a massive bundle of cordage. This was not ordinary rope. While hemp could be used in a pinch, the best bundles were made from animal sinew or even human hair. Sinew, taken from the legs of oxen or the necks of horses, was favored because of its incredible elasticity and strength. These fibers were cleaned, dried, and treated with oil and animal fat to keep them from becoming brittle. They were then twisted into a thick, vertical cable. This bundle was the battery of the onager. To arm the weapon, a single heavy wooden arm was inserted into the middle of this twisted bundle. Using a system of bronze ratchets and heavy winches called windlasses, a crew of up to 8 men would pull the arm down toward the rear of the machine. As the arm moved, it forced the bundle of sinew to twist even tighter. This was physics in its most literal form. The mechanical energy from the soldier's arms was being converted into potential energy stored within the microscopic fibers of the sinew. Every inch the arm moved increased the internal tension. The bundle wanted to untwist, to return to its natural state, and it held that desire with thousands of pounds of force. By the time the arm was locked into the firing position, the machine was a coiled predator, vibrating with the need to release. Roman engineers were masters of calibration. They knew that if the tension was uneven, the arm would veer to one side or the bundle would snap, potentially killing the crew. To prevent this, they used notched bronze caps at the top and bottom of the bundle. These caps allowed the engineers to fine-tune the tension using iron pins, ensuring that the energy was perfectly balanced. They even accounted for the weather. In humid environments, sinew expands and loses tension. In dry heat, it can become too tight and snap. Roman artillery officers had to be part scientist and part mechanic, constantly adjusting their machines to match the environment. This was not a weapon you simply pointed and fired. It was a high-performance engine that required constant maintenance and a deep understanding of material limits. The release of this energy was instantaneous and terrifying. When the locking pin was knocked away, the arm snapped upward in a blur of motion. In the early days of the onager, the arm ended in a carved wooden bucket that held a stone. However, Roman engineers eventually realized they could improve the design. They replaced the bucket with a long leather sling. This was a stroke of genius. The sling acted as a second lever, effectively lengthening the arm of the catapult without adding any extra weight. As the arm swung upward, the sling would whip around the tip, accelerating the projectile to even higher speeds. This use of centripetal force allowed the onager to throw stones further and harder than ever before. A stone weighing 100 pounds could be launched across a distance of 400 meters or more. Imagine standing on a city wall and seeing a rock the size of a human head hurtling toward you at over 100 miles per hour. The sound alone was enough to break the will of defenders. The projectile did not just hit the wall. It punched into it. It turned stone into dust and splintered wooden gates like they were made of dry twigs. At the siege of Jerusalem, the historian Josephus recorded that the stones launched by Roman engines were so large and moved so fast that they could take off the heads of men standing on the ramparts and keep going, smashing through buildings deep inside the city. The impact was described as a clap of thunder that echoed through the streets. The onager was also a masterpiece of modular design. Because it was simpler than the two-armed ballista, it could be built and repaired more easily in the field. Each Roman legion typically traveled with 10 of these machines. They were not transported fully assembled. Instead, they were carried on heavy ox-drawn carts in sections. When the army reached the city they intended to besiege, the engineers would scout the local forest for the best timber. They would use the metal parts they carried with them, the winches, the bronze caps, and the iron plates, and combine them with fresh wood to build a battery of onagers right on the spot. This allowed the Romans to maintain a constant state of mobility. They did not need to drag massive, fragile machines across mountains. They carried the heart of the machine and built the body wherever it was needed. But the real secret to the onager's success was how the Romans used it as part of a system. It was rarely fired alone. Instead, a line of onagers would be coordinated to strike the same section of a wall at the same time. This was rhythmic destruction. One stone would crack the outer facing of a wall, the next would widen the gap, and the third would collapse the internal rubble core. While the onagers dealt with the heavy masonry, the smaller ballistae and Scorpios would fire at any defenders who tried to repair the damage or return fire. It was a combined arms approach that turned the siege into a factory of demolition. The recoil of the machine remained its greatest challenge. To keep the onager from shaking itself to pieces, the Romans built a massive horizontal stop bar. This beam was wrapped in thick layers of wool or hide and padded with bags of hair to absorb the impact of the arm. Even with this padding, the force was so great that the machines were often placed on beds of loose earth or specially constructed wooden platforms that could slide slightly to dissipate the energy. This was early shock absorption technology. Without it, the onager would have been a single-use weapon, destroying itself with the very first shot. As we look back at the onager, we see a weapon that represents the Roman mindset perfectly. It was practical, it was powerful, and it was relentlessly efficient. It took the biological materials of the natural world, wood and sinew, and forced them to obey the laws of physics in the most violent way possible. It was a machine that proved no wall was high enough and no gate was strong enough to keep Rome out. The onager did not just win battles. It ended them. It turned the complex art of defense into a simple question of how much weight a wall could take before it crumbled. But as terrifying as these engines were from a distance, the Romans knew that machines alone could not hold territory. A wall could be broken by a stone, but a province could only be held by the men who followed in the wake of the dust. The physics of the onager cleared the path, but it was a calculated structure of the Roman military that truly made the empire unstoppable. The machines were the roar of Rome, but the soldiers were its heartbeat. And as the dust settled from the latest volley of stones, the enemies of Rome would look out from their ruined walls to see something even more organized and even more permanent than a catapult. They would see the Roman camp, a city of iron and discipline rising from the earth in a single night. If a ballista was a heavy hammer of the Roman army, the Scorpio was its scalpel. While massive stones could crush walls and collapse towers, they were often slow and lacked the surgical precision needed to eliminate a single target in the middle of a chaotic battlefield. Roman engineers realized that raw power was useless if it could not be directed exactly where it was needed most. They wanted something smaller, faster, and more terrifying. They wanted a weapon that could reach across hundreds of meters to pick off a commander, a standard bearer, or defend on a wall before they even knew they were in danger. This was the Scorpio, the weapon that brought the concept of sniping to the ancient world. It turned the art of war into a calculated science of distance and death. At first glance, the Scorpio looked like a cross between a giant crossbow and a mechanical insect. It was a torsion engine, meaning it relied on the same principle of twisted fibers as a larger ballista, but it was refined for speed and extreme accuracy. The name itself, Scorpion, came from the way the weapon looked when it was cocked and ready to fire. The iron arms pulled back like the pincers of a desert predator, and the deadly bolt sat ready to strike like a tail. This was not just a bigger version of a bow. It was a masterpiece of mechanical tension. Roman engineers used bundles of horsehair or animal sinew, often soaked in oil to keep them flexible and strong even in the humidity of a northern forest or the heat of a desert. These bundles were threaded through bronze washers and tightened using iron pins until they held enough energy to launch an iron-tipped bolt with enough force to pierce a shield and the man behind it in a single motion. Precision was a hallmark of the Scorpio. Unlike the larger catapults that required a team of men to aim and fire, the Scorpio could be operated by a single skilled soldier. This operator was a specialist, an ancient marksman who understood the subtle mathematics of wind, distance, and gravity. Vitruvius, the great Roman architect and engineer, wrote extensively about the tuning of these machines. He explained that a well-made Scorpio had to be calibrated based on the diameter of the torsion holes. This allowed for a standard of production that meant every machine performed predictably across the entire empire. In the heat of battle, a Roman officer did not have to guess how far his bolt would fly. He knew exactly where it would land because the engineering was that consistent. This was the birth of standardized weaponry, where a machine from a shop in Rome worked exactly like one built in a camp in Gaul. Imagine being a tribal warrior standing on a hill, watching the Roman legions approach. You feel safe because you are beyond the reach of their spears and arrows. You are shouting insults and waving your weapon. Then you hear a sharp, metallic snap, like the sound of a heavy branch breaking under immense pressure. A second later, your commander, who was standing right beside you, is knocked off his horse. There was no whistling arrow, no visual warning, just a heavy iron bolt that struck with the force of a falling tree. That was the psychological horror of the Scorpio. It was silent until it was too late. It turned the battlefield into a place where nowhere was truly safe. At the siege of Avaricum, Julius Caesar described a Gallic warrior who stood on a wall, throwing grease into a fire to burn Roman siege works. A Scorpio bolt struck him down instantly. Another warrior stepped up to take his place, and he too was killed by a bolt from the same machine. This happened again and again until the position was abandoned. This was not just a weapon. It was an executioner that broke the will of the enemy through repeated, unavoidable loss. The Scorpio was also incredibly mobile. While a massive onager had to be built on site or moved slowly by teams of oxen, the Scorpio was light enough to be carried on a cart or even on the shoulders of a few men. This mobility gave the Romans a level of field artillery support that no other army in history could match for centuries. Each legion was typically equipped with 60 of these machines, one for every century of soldiers. This meant that when a Roman army took the field, they were supported by a battery of 60 snipers. They could set up on a ridge or behind the safety of the shield wall and rain down a constant stream of high-velocity bolts. These bolts were often made entirely of iron or heavy wood with a thick metal head. They were designed to fly flat and fast, making them much harder to see or dodge than a traditional arrow. In a world where shields were the primary defense, the Scorpio made those shields feel like paper. As the Roman military evolved, so did the Scorpio. By the 2nd century, they had developed the ballista, which was essentially a Scorpio mounted on a horse-drawn carriage. This was the birth of mobile artillery. Now, the Romans could move their snipers around the battlefield with the speed of cavalry. They could reposition to flanking angles, harass retreating enemies, or provide cover fire for advancing infantry without ever stopping to dismantle their gear. The carriage provided a stable platform for the machine, and the crew could fire while on the move or stop briefly to deliver a devastating volley. This prevented the enemy from ever finding a safe spot to regroup. If they stood still, the Scorpio picked them off. If they ran, the ballista chased them down. It was a relentless system of pursuit and lethality. The design of the Scorpio also included several advanced features that showed the brilliance of Roman smiths. They used notched bronze plates to lock the tension at different levels, allowing the operator to adjust the range with a simple click. The trigger mechanism was a work of art, a metal claw that held the tension of the string until a lever was pulled. This allowed for a smooth release that did not jerk the machine, preserving the aim of the operator. The bolts themselves were often flight stabilized with leather or wooden vanes, ensuring they stayed on target even over long distances. Some versions even used metal tubes to guide the bolt, further increasing the accuracy. It was a level of detail that would not be seen again until the Industrial Revolution. In naval warfare, the Scorpio was just as deadly. Placed on the decks of Roman galleys, they were used to clear the enemy decks before boarding. A single bolt could punch through the wooden bulwarks of a ship and kill the oarsman or the captain. Because the weapon had such a flat trajectory, it was perfect for the horizontal nature of sea combat. While archers had to deal with the swaying of the ship and the arc of their arrows, the Scorpio operator could point and shoot directly at the target. This gave the Romans a massive advantage in the early stages of a naval engagement, softening up the enemy before the boarding bridges were even dropped. It turned ships into floating fortresses of precision fire. The legacy of the Scorpio is found in the way it changed the mindset of the Roman soldier. It taught them the value of technological superiority. They did not just rely on their strength or their numbers. They relied on their ability to out-engineer the enemy. The Scorpio proved that a small group of specialists with a well-designed machine could hold off an entire army. It forced their enemies to change how they fought. Tribes that used to rely on large, dense formations found themselves vulnerable to the concentrated fire of the Scorpion batteries. They were forced to scatter, making them easier for the Roman infantry to hunt down and destroy. The Romans used their machines to dictate the geometry of the battle, forcing the enemy to move exactly where the legionaries wanted them. The Scorpio also played a vital role in the defense of the empire. On the battlements of Hadrian's Wall or the forts along the Danube, these machines were kept in covered positions, ready to fire at anyone who approached the border. Archaeologists have found hundreds of Scorpio bolt heads in these locations, proving that they were a constant presence in the daily life of a frontier soldier. The sight of the wooden frames and bronze caps on the walls was enough to discourage most raids. It was the ultimate deterrent, a weapon that promised a quick, unseen death to anyone who dared to challenge the power of Rome. The soldiers who operated them were the guardians of the border, using machines to stretch their reach far beyond the stone walls they defended. When you look at the Scorpio, you see the bridge between ancient combat and modern warfare. It was the first time an army used precision technology to dominate the battlefield from a distance. It was not about the glory of a sword fight or the weight of a shield. It was about the cold, calculated efficiency of the machine. The Romans understood that if you can kill your enemy before they can reach you, you have already won the battle. They took the raw power of torsion and shrunk it down into a weapon that could be aimed with the tip of a finger. It was the sting of the Scorpion, a lethal strike that made the Roman army the most feared force in the ancient world. Even the maintenance of these machines was a feat of organization. Roman legions traveled with a corps of engineers and carpenters known as fabri. These men were responsible for keeping the Scorpio batteries in perfect working order. They carried spare sinew, extra bronze washers, and thousands of pre-made bolts. They knew that a single loose pin could mean the difference between a hit and a miss. This level of logistical support ensured that the Scorpio was always ready to strike. It was not just a weapon they used occasionally. It was a core part of their tactical doctrine. They treated their machines with the same discipline they applied to their formations. The evolution from the heavy, clumsy catapults of earlier eras to the sleek, precise Scorpio represents the peak of Roman war tech. It shows a civilization that was obsessed with perfection and domination through design. They did not just want to win. They wanted to win with the least amount of risk to their own men. By using the Scorpio, they could break the enemy's spirit in their ranks before the first legionary even drew his gladius. It was a philosophy of war that favored the smart over the strong, the engineer over the brawler. And in the end, it was that philosophy that allowed Rome to build an empire that stretched across the known world, held together by iron, sinew, and the terrifying accuracy of the scorpion. Imagine the sound of 60 scorpions firing at once across a flat plain. It would not be a roar, but a rhythmic clicking and snapping, followed by the hiss of bolts cutting through the air. To an enemy, it must have sounded like the machinery of fate itself. There was no way to hide, no way to block, and no way to fight back against an enemy you could not reach. You could only hope that you were not the next target in their sights. This was the birth of sniping, the moment where lethality became a matter of precision rather than just power. The Scorpio did not just kill. It sent a message. It told the world that Rome was watching, and their reach was longer and more deadly than anyone ever imagined. Imagine a machine that is not made of gears, pulleys, or wood, but of flesh, bone, and bronze. A machine that could breathe, walk, and turn as a single, massive organism. What if we told you that Rome's most terrifying war machine was not a catapult or a siege tower, but the soldiers themselves? When you think of the Roman legion, you probably picture a line of men charging into battle. But the true genius of Rome lay in their ability to transform a group of individuals into a moving fortress. In this segment, we explore the mechanics of the testudo and the incredible engineering behind Roman fortifications. How did a simple formation become a shield that even falling rocks couldn't break? What kind of discipline allowed an army to build a city out of the dirt in just a few hours? This was a technology of order, a system that turned every soldier into a brick in a wall that never stopped moving. To understand the testudo, or the tortoise, you first have to understand the tool that made it possible. The scutum was the iconic rectangular shield of the Roman legionary, and it was a masterpiece of ancient engineering. Unlike the round shields of the Greeks, which were designed for individual protection in the phalanx, the scutum was curved like a section of a cylinder. This curvature was not just for style. It was a brilliant structural choice. When a soldier held the scutum against his body, it wrapped around his sides, protecting his ribs and his hips. It was made from 3 layers of thin wood strips, glued together with bovine glue in alternating directions. This created an early form of plywood, a material that was incredibly strong, flexible, and resistant to splitting. If an arrow hit a solid piece of oak, the oak might crack. If it hit a scutum, the layers of plywood absorbed the energy and trapped the tip. The edge of the shield was reinforced with iron or bronze to prevent it from fraying under sword strikes, and the center featured a heavy metal boss called an umbo. This boss served a dual purpose. It protected the hand that held the horizontal grip behind it, and it turned the shield into a blunt force weapon. A legionary did not just hide behind his shield. He punched with it. In the middle of a crowded battle, a jab from a heavy bronze umbo could shatter a man's jaw or collapse his chest. But the real magic happened when those shields came together. This was the testudo. At a single command, the front rank would lock their shields together in a solid wall. The second, third, and fourth ranks would raise their shields over their heads, overlapping the edges like the scales of a serpent or the plates on a tortoise shell. The soldiers on the flanks would turn their shields outward, closing the gaps on the sides. The result was a completely enclosed box of wood and metal. This was not a loose group of men. It was a structural unit. From the outside, The testudo looked like a sloping roof of bronze and leather. In sieges, this allowed the Romans to march right up to the base of an enemy wall while a literal rain of projectiles fell upon them. Arrows, javelins, and even heavy stones would simply bounce off the top and slide down the back. Ancient accounts describe how the formation was so strong that men could actually walk across the top of the shields as if they were a solid floor. In some demonstrations, even heavy chariots were driven over the roof of a testudo to prove its structural integrity. It was the ancient version of an armored personnel carrier, a way to deliver a payload of deadly infantry into the heart of an enemy position without losing a single man to long-range fire. But the testudo was more than just a defensive posture. It was a psychological weapon. Imagine being a defender on a city wall, pouring everything you have down at the attackers. You throw rocks, you fire arrows, you pour boiling oil, and yet the strange, wooden beast below you just keeps crawling forward. It does not break. It does not scream. It just moves with a slow, rhythmic thud of thousands of sandals. This was the mechanical precision of Rome. They did not rely on individual bravery. They relied on the system. Of course, the testudo was not invincible. It was slow, and it made it difficult for soldiers to use their swords. If the formation was broken by heavy cavalry or specialized weapons, the men inside were vulnerable. But against the standard defenses of the ancient world, it was an unstoppable force of nature. However, Rome's mastery of the moving fortress did not stop when the battle ended. In fact, their most impressive feat of engineering happened every single evening. While other armies would simply find a clearing and go to sleep, the Roman legion built a city. This was a castra, the Roman marching camp. What if we told you that every night a Roman army could construct a fully fortified base from scratch in less time than it takes to cook a modern dinner? This was not just a camp. It was a laboratory of logistics. The moment the army stopped for the day, the engineers and surveyors took the lead. They used a tool called the gromma, a cross-shaped instrument with plumb lines, to mark out a perfect grid. Within minutes, the layout of the entire camp was established. Every soldier knew exactly where his tent would be. Every unit knew which section of the wall they were responsible for building. The process was a masterpiece of synchronized labor. While one group of soldiers kept watch, others began to dig. They created a fosse, a deep V-shaped ditch that surrounded the entire perimeter. The earth they dug out was thrown in to create an adja, a massive rampart or mounded date. On top of this mound, they placed the sudes. These were wooden stakes, pointed at both ends and narrowed in the middle, which every legionary carried on his back during the march. When lashed together, these stakes formed a palisade that was almost impossible to pull apart. In a matter of hours, the army was no longer sitting in an open field. They were inside a fortress with towers, gates, and a clear line of sight in all directions. This engineering discipline meant that a Roman army could never be truly surprised. They brought their safety with them. It did not matter if they were in the middle of a thick forest in Germany or the burning deserts of Mesopotamia. The camp was always the same. This consistency was a massive advantage for morale and efficiency. A soldier who woke up in a camp in Britain knew exactly where the commander's tent was, where the food was stored, and where the nearest gate was, even if he had never been to that specific location before. The camp was a piece of Rome that they carried with them across the world. It was a physical manifestation of their belief in order over chaos. The engineering of these camps was so advanced that many of them eventually became permanent cities. The grid systems of places like Vienna, Chester, and Turin are built directly on top of the original Roman camp layouts. The Romans understood that war was not just about the moment of impact. It was about the ability to sustain yourself in hostile territory. By building these fortifications every night, they transformed the landscape. They turned the wilderness into a controlled environment. They were not just soldiers. They were surveyors, ditch diggers, and architects of domination. When an enemy looked across the field and saw a fortress where there had been nothing but grass the day before, they realized they weren't just fighting a group of men. They were fighting a civilization that could reshape the earth itself. This combination of the testudo and the marching camp created a terrifying momentum. The Romans could move across a continent like a slow, grinding machine. They shielded themselves from projectiles during the day and lived behind walls during the night. They eliminated the variables of weather and terrain through sheer engineering will. They turned the art of war into a science of construction. Every shield was a piece of a roof. Every spade was a tool for a wall. Every soldier was a component in a vast, modular system designed to survive and conquer. As we look at these war machines, from the terrifying power of the ballista to the architectural precision of a marching camp, we see a pattern. Rome did not win because they had better muscles or bigger hearts. They won because they had better systems. They treated the battlefield like a construction site, and the enemy like a structural problem to be solved. They were the first to realize that a well-engineered defense is the best offense. It makes you wonder, if the Romans could achieve this level of efficiency with nothing but wood, leather, and iron, what could they have done with the materials we have today? Their machines were not just tools. They were the foundation of an empire that refused to be stopped. And as the legion moved forward, shield to shield and brick by brick, they proved that the greatest weapon of all is a mind that knows how to build. If you look at each Roman invention on its own, you see a masterpiece of ancient engineering. The ballista was a marvel of physics. The gladius was a triumph of metallurgy. The siege tower was a giant of mobility. But if you step back and look at the Roman Empire as a whole, you start to realize something far more profound. These weren't just isolated tools of war. They were the individual cogs of a much larger, more terrifying machine. The greatest invention Rome ever produced wasn't a single weapon made of wood or iron. It was a Roman army itself, designed to function like a massive, unstoppable clockwork engine. For the Romans, war wasn't an art form or a series of heroic duels. It was a process. It was an industrial enterprise that turned raw resources into conquered provinces with the cold, calculating efficiency of a factory line. To understand how they became unstoppable, we have to look at the blueprints of this machine and see how every part, from the lowest soldier to the longest road, was engineered for total domination. The first part of this machine was standardization. In the ancient world, most armies were a chaotic collection of tribes, mercenaries, and local militias. Every man brought his own weapon, his own style of fighting, and his own level of discipline. This made them unpredictable and difficult to manage. The Romans took a different path. They realized that if you wanted to build an empire that lasted centuries, you couldn't rely on individual heroics. You needed a system. They turned their military into a standardized operation where every piece was interchangeable. Every legionary was trained in the same way, using the same tactics, and carrying the same equipment. If a soldier fell in battle in the forests of Germania, a replacement from a training camp in Italy could step into his place and know exactly what to do. He knew where to stand in the formation, how to lock his shield with a man next to him, and how to use his gladius with the same mechanical precision as the man he replaced. This was mass production applied to human beings. It meant the Roman war machine didn't just fight. It self-repaired. This standardization extended to their technology. A Roman bolt for a ballista was manufactured to a specific set of dimensions, so it could be used by any unit across the entire empire. Iron plates for armor and nails for boots were produced in massive quantities in state-run workshops. This was the birth of military logistics. By creating a uniform system, Rome ensured that their army was always fueled and ready. While their enemies struggled to find the right size of arrows or specific types of spearheads, the Romans were drawing from a limitless supply of standardized parts. This logistical backbone was the oil that kept the cogs of the empire turning. It allowed them to maintain a presence in distant lands for decades, outlasting their opponents not through better luck, but through better planning. The second core component of the Roman machine was the concept of the modular fortress. We have already seen how the Roman could build a camp or castra in a single night, but the true genius of this was its predictability. Every camp across the empire was a mirror image of every other camp. This was more than just a place to sleep. It was a psychological and tactical anchor. A soldier could be moved from the deserts of Judea to the hills of Britain, and upon entering a new camp, he would immediately know where the water was, where the food was kept, and where his commander's tent stood. The camp was a piece of Roman territory that they carried with them. It was a repeatable algorithm. By following the same grid every night, they eliminated the chaos of the march and replaced it with the comfort of a routine. It meant that even in the heart of enemy territory, the Roman army was always home. This modular thinking allowed them to expand their borders with a sense of inevitability. They weren't just invading land. They were installing a system, brick by brick and trench by trench. But a machine is only as good as the roads it travels on. This brings us to the circuitry of the empire. The Roman road system was perhaps the most vital part of their war machine. These weren't just paths for travelers. They were high-speed corridors designed for the rapid movement of heavy machinery and large bodies of troops. A Roman road was an engineering feat in itself, built with layers of sand, gravel, and stone to withstand the weight of thousands of marching men and ox-drawn carts carrying siege engines. Because these roads were straight and durable, the Roman army could move faster than any other force in history. They could respond to a rebellion on one side of the empire before the rebels even knew the legion had been alerted. This speed turned the Mediterranean into a Roman lake and the surrounding lands into a giant, interconnected battlefield where the Romans always held the initiative. The roads were the delivery system for the machine, ensuring that the hammer of Rome could fall anywhere at any time. The Romans also treated the terrain itself as something to be engineered. When they encountered a river, they didn't look for a shallow place to cross. They built a bridge. When they faced a mountain, they carved a path through it. One of the most famous examples of this engineering mindset occurred during Julius Caesar's campaign in Gaul. To intimidate the Germanic tribes, he decided to cross the Rhine, a river so wide and fast that no army had ever crossed it before. Instead of using boats, Caesar ordered his engineers to build a massive wooden bridge. They did it in just 10 days. It was a display of sheer mechanical will. Once he crossed and made his point, he tore the bridge down. He didn't just want to cross the river. He wanted to show the world that nature itself could not stop the Roman machine. This ability to reshape the world to fit their needs made them terrifying to their enemies. It was a message that resistance was futile because the Romans would simply build a way over, under, or through any obstacle you put in their path. The human element of the machine was just as carefully calibrated. The centurions and officers were the operators of the engine. They didn't just lead men. They managed a complex organization. Training was relentless and focused on turning the soldiers' instincts into mechanical responses. A legionnaire didn't have to think about whether to stay in formation when a cavalry charge approached. His body moved on its own, programmed by years of repetition. They practiced marching with heavy packs, which were famously called the mules of Marius, to ensure every man was a self-sufficient unit. They practiced the move from column to line and from line to square until it could be done in total silence and total darkness. This level of drill turned a collection of individuals into a single, cohesive organism. When the Roman line moved forward, it didn't look like a crowd of people. It looked like a wall of iron and wood, advancing with a rhythmic, terrifying, steady beat. This systematic approach to war also included the way they handled failure. When a part of a machine breaks, you analyze why and you fix a design. The Romans did the same with their defeats. After losing sea battles to the Carthaginians, they didn't just build more ships. They invented the corvus to change the nature of the fight. After struggling against the tactics of the Parthian horse archers, they adjusted their formations and incorporated their own auxiliary cavalry. They were constantly iterating, constantly improving the design of their war machine. They were the world's first true military scientists. They kept records, they studied their enemies, and they adapted. This was a culture that valued results over tradition. If a better sword existed, they stole the design. If a better siege engine was found, they built a larger version of it. They were a civilization of engineers who looked at the world and saw a series of problems that could be solved with the right tools and the right system. In the end, this is why Rome was unstoppable. Their enemies were often brave, and sometimes they were even better fighters on an individual level. But they were fighting against a machine that didn't get tired, didn't lose its memory, and didn't stop growing. The Roman war machine was a cycle of production, deployment, and fortification that repeated itself across 3 continents for hundreds of years. It was an empire of the cog, where every person and every invention played a specific role in a grand, calculated design. They turned the chaos of the ancient world into a laboratory of destruction and an office of administration. When a Roman legion appeared on the horizon, the enemy wasn't just looking at soldiers. They were looking at the end of their world and the beginning of a new, highly organized reality. So, next time you hear about ancient history, try to picture an army that carried its own city on its back, built fortresses overnight, and turned every battle into a calculated system. The Romans didn't just fight with weapons. They fought with design, discipline, and a mindset centuries ahead of their time. And it makes you wonder, in a world full of modern tools and technology, are we still as efficient as they were with only muscle, iron, and will? The legacy of the Roman machine lives on in every factory, every supply chain, and every organized military in the world today. They were the first to realize that to conquer the world, you don't just need a bigger sword. You need a better machine. And for 1,000 years, no one built a machine better than Rome.